are biological polymers. So if we start with a related compound, which everybody else has obviously heard of, cellulose, which is a polymer of glucose. We have a ring structure. And this just sort of continues along. This is just part of what goes on in an overall chain. And I'm going to focus on this part right here. So I'm going to write that in a different color. Let me do it in red so it's visible. So this material right here, or this structure I've drawn, is glucose, which forms the polymer cellulose, which is the most abundant biological polymer on the planet. If we look at chitin, very, very similar to this. So we start off with somewhere in the middle of the chain. It's just a long chain. It's the same six-membered structure. That's a 2. And on that particular carbon atom, all these little joints here are carbon atoms, we have this structure. Oops, I messed up already. Let me do something else here real quick. Do a different color. There's a nitrogen in there. And we have, let me go and use another color. All right, so that's the basic repeating unit in chitin. And this base substance here has a quite long name to it. It's N-acetyl glucosamine, UCOS. Now when we get to chitosan, we start off with this structure. When we go to chitosan, what we're doing is we're going to remove this portion, which is called an acetyl group. And the process from chitin to chitosan is a process called make sure I spell this right. Deacetylation. So we're removing this acetyl group. So if we look at that base structure, the material is now glucosamine, and that's related to chitosan. And down here, let me get my right color, we have that. So this is the basic chemical difference between the structures of cellulose, chitin, and chitosan.